Hello students, so here we are with the question third of the exercise 4.3 of the chapter Quadratic Equations. So the question third is find the roots of the following equation, and the first equation being provided is x minus 1 by x is equals to 3, and the condition for the values of the x is x cannot be equal to 0. Why this constraint is on the value of the x? See, if we put the value x is equal to 0 in this very equation, that is x minus 1 by x is equals to 3, then this term will be 0, which is okay, and this term, that is 1 by x, will be 1 by 0, which lead it to the infinite term, which is not existing one, that is, it is not a practical term. So x value cannot be equal to 0 for these equations to exist. So if I multiply both the sides of this very equation with x, so here it will be x into x minus 1 by x is equals to 3 into x, right? So on simplifying, I'll be getting x square minus 1 is equals to 3x. Now take the term 3x to the words left hand side, so here I'll be getting x square minus 3x minus 1 is equals to 0. Clearly the equation obtained is a quadratic equation because the highest degree of this very equation is 2. Now if I need to solve this equation, I can use the quadratic formula as well. So comparing this equation with the standard equation, that is ax square plus bx plus c. So from here a will be equal to 1, b will be equal to minus 3 and c is equals to minus 1. So applying the quadratic formula, x is equals to minus b plus minus root b square minus 4ac divided by 2a. Substituting the value of the a, b and c in this formula, here I will be getting x is equals to minus into minus 3 plus minus root 13 divided by 2, or I can write it as x is equals to 3 plus minus root 13 by 2. So writing plus minus term separately, here x will be equal to 3 plus root 13 by 2, and the second root of x will be 3 minus root 13 divided by 2. So these are the two roots of this very quadratic equation which have been provided in part A. Now coming to the second part, here the equation being provided is 1 by x plus 4 plus 1 by x minus 7 is equals to 11 by 30. Here again the restriction on the value of the x is x cannot be equal to minus 4 and 7, right? So in order to solve this equation, here I will be multiplying both the sides with x minus x plus 4 and x minus 7 term. So here it will be x plus 4 plus x minus 7, and on the right hand side it will be 11 into 11 by 30 into x plus 4 into x minus 7. So on simplifying, I will be getting x plus 7 minus x plus 4 is equals to x square minus 3x minus 28 into 11 by 30. So on subtracting x minus 7 with x plus 4, here I will be getting minus 11 is equals to x square minus 3x minus 28 into 11 by 30. 11 and 11 will cancel out on both the sides. So here it will be minus 1. So on simplifying, it will be minus 1 is equals to x square minus 3x minus 28 divided by 30. Or on cross multiplying, it will be x square minus 3x minus 28 is equals to minus 30. Now taking the term minus 30 to the left hand side, here it will be x square minus 3x plus 2 is equals to 0. Again applying the quadratic formula, here x comes out to be equal to 3 plus minus 1 divided by 2 Writing plus minus sign separately, here it will be x is equal to 3 plus 1 by 2 and 3 minus 1 by 2. So, x will be equal to 2 and 1. So, 2 and 1 are the roots of the quadratic equation second being provided in question third. So, this was about the question third of exercise 4.3. I hope this question is clear to all of you.